Okay, and our last video for lesson 3, part 3, we're going to talk about step functions, piecewise functions, and odd and even functions. So step functions are something that look like this. And again, it's where, like, say you could only have integers or like whole numbers. So maybe I started at something like -2. And so here I go all the way from -2 to -1, but I have an open circle. So it can be -2. It can't be -1. And then it jumps up. So when it's -1, it's up here, but it can't be 0. And then here is my whole number, but it can't be 1. 2, 3, 4. 1, 2, 3, 4. So then let's say when I hit x equals 1, it jumps up to y equals 1. Closed circle means it's an inclusive. Open circle means it's exclusive. Okay? Oops. So we're step functions. It's like you're stepping up. You're jumping levels. Okay? So how do we do that on Desmos? You're going to go to the Functions tab. You can go all the way over to Miscellaneous. You're going to hit Floor. And then you would plug in whatever you wanted. If you wanted to plug in floor of -1. That didn't work. It would have to be x. See here, floor of x would just be normal. You could do x minus 1. You could do floor of 2x. Again, you can kind of see how this works. Maybe it's a combination 2x minus 3. Okay, so again, you can look and you can say, oh, if I were to zoom in, okay, here it equals 0 to 3. Over here, I can't equal this one, right? It jumps up. So it has to jump up here. Come on. See how y doesn't change? And then it jumps. My x's are changing, but my y's are not changing. So that's what we call a step function. We've talked about piecewise functions before, okay? So again, piecewise functions, it's like when you have multiple functions that are combining to solve the problem or to create the function. So for example, we might have f of x equals, and then this just is like our symbol for includes. It could be 2x plus 3 for all numbers where x is less than or equal to 1. But if x is greater than 1, again, if x is greater than 1, then I might use the function x plus 4. So let's go ahead and type that into Desmos. 2x plus 3, and then remember, you have to include these symbols, and then you have to specify when x is less than or equal to 1. And let's see if that, oops, and then I have to hit shift and then close it. And then let's check out our function. I think I got to get rid of that comma. There we go. No comma needed. Okay, so that's our function 2x plus 3. And now our second function was -x plus 4. I got to use, so again, see how I haven't specified where it goes. So it's just going all the way across. But I need to specify only for numbers that are greater than 1. X is greater than 1. Now, as I close it and I drag my cursor, okay, again, I can see we can see how it it kind of jumps, it skips steps. And now we have to be conscious because this first equation, the black line, has the equal to. So if x equals 1, this number would be 5, okay? This would be x is 1, y is 5. And then if I jump down here, I can see, hey, x cannot equal 1 because when x doesn't equal 1 because of our equation. When x equals 1, it's up here. It's right here. So that's why it says this is like our, when x is 1, it's our open circle. Or this, when x is equal to 1, it's our closed circle. And then this one would be our open circle where it doesn't exist. It's undefined. And that would go on forever. So we can kind of draw something like that. Again, it looks something like this. We had a line. It went all the way to here. At x is 1, we had our closed circle. And then we had our open circle right here. And then x continued on forever. So that's how we graph piecewise functions. And now our last kind of step is even and odd functions, okay? Even and odd functions. So in general, okay, we take our function. So this is for even. Normally our function is f of x, correct? So what we do is we're going to say a function f is even for each x in the domain if I can change, okay, if I can make all my x's a negative and it equals f of x, that's going to be even. So an example of an even would kind of be, it's going to be symmetric to the y-axis. So what does this mean? So let's say that this point is -2 and this point is +2. So I want to find when x is 2, okay? So I say, hey, f of x, f of 2 equals, well, in this, let's choose a different point that's not on 0. So we're going to choose, okay, 2, -2. So let's choose this one. Let's say that this is 1 and this is 1. So if I say that, hey, f of 2 equals 1, f of -2 should also equal 1. And in this case, we can see, yes, that is true. So we would say that this is an even function because f of -x and f of x are the same thing, which is kind of similar but slightly different to odd functions where it says, hey, f of -x is equal to -f of x. So again, what does that mean? That means that I'm symmetric to the origin. So if I drew an example of this, it might look something like this. So I have a point here. Again, this is x comma y. I have a point here. This is -x, -y. Whatever it may be, we can call it, I don't know, we can call it -2 and +2. So I can see, hey, all right, if I took f of 2, it would equal 2. But if I took f of -2, it's going to equal -2. Again, notice where these negative signs are in the equation. F of x is very similar, like we kind of talked about. F of x is really similar to y. So if you think about our ordered pair, x comma y, f of x, this part right here is x. The entire thing, f of x, is like what we call our y. So f of -2 equals -2. And again, it's symmetric to the origin. So maybe we add those notes in. Even functions, symmetric to the y-axis. Odd functions, symmetric to origin. And in our case, the origin is 0, 0. So if I look here and I look here, it better be the same distance for both. It's got to be the same distance for both. Which means, of course, there's always those examples where if it's even, it's odd. What happens if it's neither? So you might get a graph. Holy smokes. Look how big that line is. How did I do that? Let's erase that. It did it again. Go to that one. Everything is happening right now. Well, we're going to make it work. Okay, I could have a function that would look something like something going up like this and something going down like this. Again, these 2 points are not symmetric to the y-axis. They are not symmetric to the origin. So we would say that this is neither. Do I have to go that small? Does that help? There, that's better. A little bit. So again, a couple ways you could test a function. Again, I would say make your whatever's inside of your f of x, make it negative. If it comes out the same, it's even. Make whatever's inside your parentheses negative. If it comes out as the entire, like the y coordinates are negative, it's going to be odd. And if you get something totally different, it's going to be neither. So real quick, let's just try one example. Let's say g of x equals x to the third minus x. So I'm going to test my function by saying, okay, let's do g of -x, which means every time I see an x, I need to make it negative, subtracting -x. So again, I made this negative, I made this negative, I made this negative. Well, we know that -x times -x times -x is still going to be -x to the third. Negative times a negative is a positive. Positive times a negative is a negative. Subtracting -x. So this negative, I call this a negative subtracting a negative. They're going to cancel out. It actually turns into a super plus. That's what I like to call them. But again, it's just a plus sign. Subtracting a negative cancels out, which means, hey, if I were to factor this negative out of both terms, I would get negative parentheses x to the third minus x, which if you look back at what we started and you look back at what our rules for odd functions are, that is exactly what we ended up with. So this function right here is an odd function. Let's just graph it just to see. So I'm going to type in x to the third minus x. Okay? And again, I can see that that is symmetric to the origin. The origin is 0, 0. So yes, that is an odd function. I guess we can do an even. Let's do an even example as well. That'll be our last example. Let's call it h of x equals x squared plus 1. Once again, I'm going to make this into a negative. So every time I see an x, I need to make it negative. Negative x times negative x is positive x squared. And that is exactly what I started with. Therefore, it is an even function. And if we were to graph it, let's just keep that one there to show us x squared plus 1. Again, this is symmetric along the y axis.